Hi kids, it's time to recap what we have learned in chapter 1 and 2. Let's begin with recap of Introduction to Matter. What is the difference between mass and volume? All matter has volume and mass. Mass is the amount of matter present in a substance. Volume is the space that matter occupies. Basically, any substance which has mass and occupies space is termed as matter. Matter occupies space irrespective of its state. Matter is made up of tiny particles and they have space between them. Each particle has the same property as the original substance. Here is the proof for it. Even after the serial dilution of potassium permanganate solution, you can still see the pink color in it. Particles of matter are in constant motion. That is the reason why when you drop an ink into a glass of water, it disperses by itself without you mixing it. Particles of matter also attract each other. This property of matter is utilized by the plants to distribute water from the roots to other parts of the plant. Now it's time to recap the states of matter. The states in which most of the matter around us occur are solid, liquid, and gases. In solids, particles vibrate in fixed position and are very compactly arranged. The attraction between the particles is very strong. The kinetic energy of the particles is very less. Hence, solids have fixed volume and shape. In liquids, particles do not have fixed positions and can slide over one another. The attraction between particles is lesser than in solids. The kinetic energy of the particles is more than that of solids. Hence, liquids have definite volume but no fixed shape. In gases, particles move randomly, freely, and very fast. Their kinetic energy is very high. There is a lot of space between the particles and hardly any attraction between them. Hence, gases have no fixed volume or shape. They can be compressed to a very great extent. The three states of matter exhibit different properties because of the following reasons. Arrangement of particles is very different, bonding between particles varies, and movement of particles is not the same. Now let us recap the interconversion of states. Change in temperature and pressure brings about change in states. State change is a physical change. As you can see here, individually the particles are the same. The change is only in the arrangement. Be aware of the color code out here. It just means that red arrow means heating and blue arrow means cooling. Let us look at these techniques. So, conversion of liquid to gas is called as boiling. Conversion of gas into liquid is called as condensation. Solid to liquid is called as melting, and liquid to solid is called as freezing. Solid to gas is called as sublimation, and gas to solid is called as deposition. Temperature at which boiling occurs in a substance is called as boiling point. Similarly, the temperature at which melting and freezing occurs in a substance is called its melting point and freezing point respectively. Let's look back at temperature and its units. Remember that we had seen that it can be represented in Celsius, Fahrenheit, and even in Kelvin. So Kelvin is nothing but adding 273 to degrees Celsius. And if you subtract 273 from Kelvin, you get back the degrees Celsius. For example, if you add 273 to 0 degrees, you're going to get 273 Kelvin. You can look at some of the temperatures that is given here, and you can see that 37 degrees Celsius or 98.6 degree Fahrenheit or 310.15 Kelvin are all the same. Latent heat of fusion for any solid is the amount of heat required to convert 1 kg of that solid into liquid at atmospheric pressure and at its melting point. Here you can see that latent heat of ice is 334 kilojoule. Latent heat of vaporization of any liquid is the amount of heat required to convert 1 kg of that liquid into gaseous form at atmospheric pressure and at its boiling point. Boiling is a bulk phenomenon. It happens when the liquid reaches its boiling point. Evaporation is a surface phenomenon that brings about a cooling effect to the surrounding. Evaporation occurs at a much lower temperature than the boiling point. Now let's recap solutions, suspensions, and colloids, which are nothing but different types of mixtures. Let's compare the size of the particles in all the three. In a solution, the size of the particle is 10 nanometer. In a colloid, it is 1 to 100 nanometer. In a suspension, it is more than 100 nanometer. And look at the distribution of these particles in all the three. In a solution, the distribution is uniform, and hence it is called as a homogeneous solution. In case of a colloid, the distribution is not uniform, hence it is called as a heterogeneous mixture. And even in case of a suspension, the distribution is not uniform, hence it is also called as a heterogeneous mixture. Let's compare their appearance. A solution looks very clear. A colloid looks cloudy, whereas a suspension also looks cloudy. Let's look at separation. If we let these three different types of mixtures to stand for a while, in a solution, nothing separates out. In a colloid, there is no separation happening, whereas in suspension, the particle starts to settle or separate. Let's compare filterability. In a solution, the particles pass through the filter, hence cannot be separated through filtration. In case of a colloid, the particles also pass through the filter, hence filtration cannot be used to separate particles in a colloid. Particles do not pass through the filter in case of a suspension, hence we can use this technique to separate the particles in a suspension. Let's look at the effect of beam of light on colloids, suspensions, and solutions. Or to be specific, we will call this as a Tyndall effect in case of a colloid. Because compared to solutions and suspensions, we will be able to see scattering of light only in case of a colloid, and that is called as the Tyndall effect. In case of a solution, the particles are too tiny to scatter light, so there is no scattering of light. In case of a colloid, as we saw already, it scatters light. In case of a suspension, initially as it is opaque because of too many suspended particles and because the particles are comparatively bigger in size, they will not let light to pass through. And later on, when the particles start settling down, they will allow the light to pass through and hence are transparent now. In the intermediate stages, it might scatter a little bit of light, hence suspension isn't consistent in showing the Tyndall effect. Here are some examples for the three types of mixtures that we already looked at. For solutions, it is any kind of juice or lemonade and soda water. For suspension, it is soil in water and Italian dressing. Finally, for colloids, it is milk, whipped cream, and butter. Let us look at how to find out the concentration of a solution. Here you can see the formulas which you can use to find out the concentration. Here are some examples. If they have given you the amount or the mass of the solvent and the solute, you can utilize mass by mass percentage way of finding out the concentration, wherein you use mass of the solute divided by the mass of the solution into 100, which is 50. The solution is 100 plus 50 because the solvent is 100 and solute is 50, so therefore you get 150 and you multiply it by 100. You're going to get 33%. If they have given you the volume of the solution and the mass of the solute, you can utilize mass by volume percentage, and that is nothing but mass of the solute divided by mass volume of the solution into 100, which is nothing but 50 divided by 100 into 100, which is going to give you 50%. Now it's time to recap the separation techniques that we have learned. Here is how we are going to look at it. We are going to look at the mixtures first, or basically what state the components are in, then the properties of the components that we can utilize, then the process or the separation technique, and then we'll look at the examples. Let's start with solid in solid. What if one of the solid is magnetic in nature? Then we can use a magnet to separate it from the rest of the mixture. The example is iron filings. What if they differed in their size and color? Then we can use hand picking or sieving. Example is stones in rice. What if one of the solid sublimated? Then we can use sublimation as the technique. Example is ammonium chloride with any other salt, camphor with other substances. Now let us look at solids in liquids. There are two types in here, one in which the solid dissolves in the liquid and in the other wherein the solid do not dissolve in the liquid. Let us look at solids that dissolve in the liquid first. The property that we will consider is that the liquid has a lower boiling point. Hence, we can make use of evaporation to separate the solid from the liquid. The example is salt and water. Next, the solid is crystalline in nature. Hence, we use crystallization to separate the solid from the liquid. Example is copper sulfate and water. Many solids have different affinity towards other substance is the next property that we are going to use. If that is the case, we can use chromatography to separate the solids from the liquid. Example is pigments in ink, plant extracts, etc. Now let us come to solids that do not dissolve in a liquid. Solid particles do not pass through the filter is the property that we are going to make use of. In that case, we can use filtration technique to separate the solid from the liquid. The example is sand and water. Next, the property we are going to consider next is the particle size and variation in densities. In that case, we can use centrifugation, wherein you can separate the mixtures based on their density. Example is colloids, milk solids from milk, water from clothes by spinning or drying in washing machine, and cells from blood. Now let us look at solids and gases. What if the particles vary in size and density? So we can make use of centrifugation again, or we can also make use of filtration technique to separate the solids from the gases. Example is to clean dirty air. Next up is liquid in liquid. What if the liquids are immiscible? Then we can use a separating funnel to separate both the liquids from one another. Example is oil and water. Next up is liquids which are miscible with each other but then have different boiling points. Then we can use distillation. Example is acetone and water, gasoline from crude oil, etc. Now let us look at liquid in gas. The property we are going to consider is variation in the ability to condense. Hence, we can use the condensation technique to separate the mixture. Example is fog. Next up is gases in liquids. Gases are lighter and have low solubility at low pressure or high temperature. So lowering the pressure by opening the cap of the soda or increasing the temperature will allow the gases to escape from the liquid. Example is carbonated water. Next up is gases in gases. The property that we are going to make use of is the difference in boiling points. We can use fractional distillation as the technique. Example is petroleum products from crude oil.